All right, analyzing lines of fit. This is example 2. So it says using residuals. The table shows the ages X and salaries Y in thousands of dollars of 8 employees at a company. The equation Y equals 0.2X plus 38 models the data. Is the model a good fit? All right, so if you remember before in the last video, in example 1, I showed you how you can use your calculator to enter this table of values. You can write an equation. You can look at the scatter plot. You can even find the Y values to calculate the residuals using that calculator. So I'm going to use the calculator because in real life, I feel like you always pretty much have a calculator available. So being able to use this is also very important. All right, so the first thing I want to do is go to Stat, and if we're going to go to Edit, all right, if there's numbers still in the table, I need to enter these numbers, so I have to clear the table. So to clear your table, you're going to go second, plus, and 4. You can see 4 says clear all list. So clear, then you have to enter. So it says done, and then I can go back to Stat, and I can enter my new table. So go to L1 and enter the table. All right, if you have a calculator, I hope you are doing this as well. The more you practice these steps, the easier it would get and the more you will remember it. If you need to pause the video for a short period of time to do it, go ahead and do that as well. All right, so kind of look over the list, make sure that you entered those correctly. If you enter a number wrong, it's going to generate the wrong equation. Also, always make sure that your list have the same number of data points here, because if it has a different number in list 2 than it does in list 1, it will say error. All right, once your list is entered, you can do second mode, which is quit. It saves that table for you, and now you can generate an equation. All right, go to Stat, over to Calculate. Again, we're working with linear equations, so we're going to do number 4, linear regression. And this generates our equation for us. Now you can see here, the R this time is only 0.41. That is closer to 0 than it is 1. So this probably is not going to be a good model. This is probably not going to be, it's not going to look very linear. So let's look at the scatter plot. Our scatter plot is on. All right. Now if we hit graph. Now again, we have to look at, let me delete that equation here. So that equation is from the last problem. All right. So if we look at our graph here, we're not seeing any points. So we need to go back to our scale. And our x's need to be up through 55 at least. So here it only goes to 20. That's why we're not seeing anything. So our lowest one is 35. So we need to go up to at least 55. So let's just do 57. All right, and our y values, 42 up through 52, and then 45. So we have to have a negative when it says minimum. If you don't have a negative here, it'll say error. So you have to have at least a negative. So I just put -2 because we don't really need any negative numbers. But for maximum, it needs to be larger than the largest number here. So larger than 52. So let's put 55. And this scale of 1 just means it's going by ones. Everything else is okay. So hit enter. And now go back to graph. So now you can see that this is like more of an upside down U shape. So it does not look very linear. So when we had the 0.4, it does not look very linear. So if we do stat, we have an equation. So let's take the equation and go y equals vars number 5 equation. This is the equation our calculator wrote for us based on this table of values. Now, does that line represent those points? No, not really. So what can we conclude by this? We can conclude that this is not a good model. This equation is not a good model, and it's not a good fit. And if you want to look at the residuals, you can do that as well. Remember, you can go second table. You can take your y values and put them down here, and then you find the difference of your y's from the table to the y's from your data set. Now this equation here should be very similar. They may have found this with 2 points instead of using the calculator. Let's just look and see how close the equation is to what the calculator gives us. 0.2, so that's the same, and plus 38, 38.09. So this is the same equation as the calculator, and you can see that this is just not a good fit. All right, example 3 says finding a line of best fit using technology. All right, great. So I've already showed you how to do this a couple times. So I want you to pause the video and see how much of this you can do on your own, and then you can come back and see if you did it correctly. So it says the table shows the duration X in minutes of several eruptions of the geyser Old Faithful and the times Y in minutes until the next eruption. Use technology to find an equation of the line of best fit. Then graph the equation with the data. Identify and interpret the correlation coefficient. Remember, that's the R when you're using your calculator. And interpret the slope and y-intercept of the line of best fit. All right, now, very quickly before you get started, if you have a calculator, if your calculator is not showing this R, let me show you how to get to that. All right, second quit. If you go to second 0, that's your catalog. All right, in your catalog, you have to scroll all the way down to find diagnostics on. You may be able to hit D and just skip down through there, but I usually just scroll down through here. And you're going to find diagnostic off and diagnostic on. So what we want, there it is. All right, so we've got diagnostic, we want diagnostic on. So we're going to hit enter, we hit enter again, and what that does is that turns on the R. That'll make sure the R is there when you write your equation. So again, second catalog, diagnostic on, enter, enter. Make sure that's in your notes so you know how to do that. All right, work this out and come back to the video when you have an answer. All right, hopefully you took time to do this. So if you took your calculator, entered the table of values, and wrote an equation using your linear regression feature, you should have got y equals 12x plus 35. I think I rounded this a bit, but that's pretty close to what you would have. So y equals 12x plus 35 is your equation. It says then graph the equation. I just graphed my equation here on my calculator as I did before. Remember, if you go to y equals, go to vars, stats, and equation, it will put your equation in there and it will graph that so you can see that is a strong positive correlation. When you wrote your equation, if you turned on your regression feature, R equals 0.98. That's very close to 1. Which you can see this is very close to these points. The line of fit is very close to those points. So that does make sense that it has a strong positive correlation. And then the last thing it says to interpret the slope and y-intercept of the line of best fit. All right, so in this case, the slope is 12. You can see the slope right here is 12. And this means the time until the next eruption increases by about 12 minutes. For each minute, the duration increases. Okay, so you can see that from the table right here. All right, the y-intercept is about 35. I rounded that a little bit, but we're going to use 35. In this case, this has no meaning because the duration cannot be 0. So your y-intercept is always going to be 0 this, but you can't have a duration of 0. So that would be how you would interpret the slope and the y-intercept of the line of best fit for example 3. All right, hopefully you are getting familiar with your calculator. This is a very handy tool. Make sure you practice using that, as that is a world of difference in saving time. All right, example 4, interpolating and extrapolating. Refer to example 3. Use the equation of the line of best fit. All right, example 3, y equals 12x plus 35. All right, use the equation of the line of best fit. So we have the equation. So it says approximate the time until the next eruption after an eruption lasting 3.5 minutes. All right, so if we refer back to this example, we can see that duration, that is your x. So all we have to do is substitute 3.5 minutes in for x. So let's do that. So y equals 12 times 3.5 minutes plus 35. All right, so let's do 12 times 3.5. 1/2 is the same as 0.5. And then we need to add that to 35. So the answer is 77. So y equals 77. So if an eruption lasts 3.5 minutes, then the time between that eruption and the next eruption is about 77 minutes. All right, let's look at B part. Predict the time until the next eruption after an eruption lasting 5 minutes. All right, we're going to do the exact same thing. We're going to have y equals 12x plus 35. We're going to do 12 times, this time it says lasting 5 minutes. And we're going to see what we get here. All right, so we're going to have 12 times 5 plus 35. And that means it's going to be about 95 minutes. So if there's an eruption that lasts 5 minutes long, if the duration is 5 minutes long, it'll be approximately 95 minutes to the next eruption. Okay, now how do you know if this is interpolating or extrapolating? Is because if the number that you entered, 3.5 minutes right here, if we go back to the table that we had, this one goes from 2 up to 3.9, okay? Or actually up to 4.4, sorry. So 2 to 4.4. Everything between that is inside the data, okay? So this is considered interpolating. 5, if you look, 5 goes outside the data. 4.4 is the largest number here. 5 is outside of that. So if you want to know what these terms in real life look like, this would be what that looks like. So this one would be considered interpolating, and this one would be extrapolating.